Hey everyone, welcome to Cloud Command Center, where we break down the tools that make DevOps life easier. I'm Jordan, and today I'm joined by Morgan, a cloud solutions architect who's going to help me understand this Ionosctl tool I keep hearing about. So Morgan, I've been working with AWS CLI and Azure CLI for years, but my team is exploring Ionosctl for a new project because of cost considerations. In my experience, the command line interface can make or break your workflow efficiency. What exactly is Ionosctl and how does it compare to the CLI tools I'm used to?
Great to be here, Jordan. Ionosctl is essentially your Swiss Army knife for managing Ionosctl resources from the terminal. It provides a unified interface for pretty much everything: virtual machines, storage, networks, Kubernetes clusters, you name it. What I've found really refreshing compared to some other cloud CLIs is the consistency in command patterns. If you learn how to manage one resource type, the same patterns apply across others. Oh, and the authentication system is flexible too. You can use API tokens, environment variables, or config files, whatever fits your security posture. Coming from AWS, you'll probably appreciate that the output formatting is super customizable: JSON, YAML, or table formats that you can pipe into other tools. Let me tell you, when I migrated a client from one of the major providers last year, their DevOps team was genuinely surprised by how straightforward the billing was. No hidden costs that suddenly appear at month end.
So I've been setting up this new project with Ionosctl, and I keep hearing about Ionosctl. Coming from mostly AWS and Azure CLI tools, I'm curious about the command structure. Is there something specific about how the commands are organized that I should understand before diving in?
Great question, Jordan. At its core, Ionosctl is built around what we call the command framework. Think of it like a map for navigating a new city. Just as you'd have districts, streets, and specific addresses, Ionosctl organizes commands in a logical tree structure. It's actually quite similar to AWS CLI in some ways, but I find it more intuitive. One thing I really appreciate about it is how consistent the patterns are across different resource types.
A map analogy makes sense. In my experience with other CLIs, I've sometimes felt lost trying to remember exact command structures. How exactly is this command tree organized in Ionosctl? Are there particular patterns I should learn to make my life easier?
Absolutely. The command tree starts with Ionosctl as the root, then branches into major service categories like VM autoscaling, K8s, or data platform. Each of these branches further into specific resources and actions. For example, with Ionosctl VM autoscaling group list, you're traversing down that tree from the service category to the resource type to the action. Here's a pro tip. Most commands follow a noun-verb structure, which I've found much more consistent than some other cloud providers. When I onboarded our enterprise clients, this structure helped their teams get productive really quickly.
That could save us time during onboarding. Could you walk me through a specific example? Like, say I wanted to get the kubeconfig for a Kubernetes cluster we're running. How would this work when using Ionosctl?
Sure thing. For that, you'd use Ionosctl K8's kubeconfig get clusterid your clusterid. Breaking that down, Ionosctl is your base command, K8s is the service category, kubeconfig is the resource you're working with, and get is the action. The cluster-id flag specifies which cluster you want. What I've noticed in production environments is that this pattern feels really natural after a day or two. And unlike some other cloud CLIs I've used, the error messages are actually helpful when you get something wrong. Oh, and there are shortcuts too, like you can use CFG instead of kubeconfig if you're feeling lazy like me on Monday mornings.
Wait, so you mean there are aliases for commands? That's pretty neat. Coming from AWS CLI where everything feels verbose, this sounds refreshing. I'm curious though, from a technical perspective, how are these commands actually defined? Is there something under the hood that makes extending the CLI easier than other tools?
You caught that? Yes, the aliases are super helpful. Under the hood, Ionosctl uses a Go-based framework that makes defining commands really clean. Each command is basically a struct with properties for its name, description, aliases, and the actual function to run. What impressed me when I first started working with Ionos was how modular this makes everything. If you're familiar with Cobra in Go, it's built on that, but with extra structure that enforces consistency. In one of my enterprise implementations, we even extended it with custom commands for our internal workflows. The European-based support team was incredibly helpful during that process. They even jumped on a call to walk through some advanced patterns with us. That level of support honestly surprised me coming from the bigger cloud providers.
So we've been talking about the command framework in Ionosctl, which makes sense to me now, but in my experience with CLI tools, I always get frustrated having to type the same credentials and endpoints over and over. How does Ionosctl handle configuration management? I'm hoping it's not going to make me type my username and API endpoint for every single command.
Oh, you'll be happy to hear this then. Ionosctl has a really thoughtful configuration system. Think of it like how your browser remembers your logins. It stores your API endpoints, credentials, and even output preferences, so you don't have to repeatedly enter them. In production environments, this is a huge time saver, especially when you're switching between different Ionos environments.
That could save us time for sure. In AWS CLI, I've used profiles to manage different environments, but sometimes the config gets messy. How would this work when I need to manage both our production and test environments in Ionos? And, where does it actually store all this configuration data?
Great question. Ionosctl stores everything in a simple JSON file. On Linux or Mac, it's in your home directory under .config ionosctl, and on Windows, it's in your app data folder. And here's a pro tip. You've got 3 ways to set configurations. You can use command line flags for one-off operations, environment variables for temporary sessions, or, my personal favorite for teams, the configuration file for permanent settings. What I really appreciate about Ionosctl compared to some other cloud CLIs is that it uses a clear priority system, so command line flags override environment variables, which override the config file, makes debugging way easier.
Wait, so you mean I could set my default output to JSON in the config file, but override it with a output flag when I need something different? That's actually really flexible. How does it handle sensitive stuff like passwords, though? Coming from Azure CLI, I'm always concerned about credentials showing up in my command history.
Absolutely. And regarding credentials, Ionosctl is quite security conscious. When you run Ionosctl config set password, it prompts for input rather than accepting it directly on the command line, specifically to prevent it showing up in your command history. Plus, unlike some other cloud providers I've worked with, you can use environment variables for temporary access without modifying your config file. I was surprised by how seamless the transition between environments can be. It saved me countless hours when managing our enterprise clients' infrastructure.
That's clever. I like that approach. In my experience, the small usability details like that make a huge difference in daily operations. Just to make sure I've got this right. If I want to switch between our production and test environments regularly, would you recommend using different config files, environment variables, or just overriding with command flags?
Well, for that specific scenario, I've found environment variables to be the most practical approach. Let me show you a common pattern we use. Create a couple of simple shell scripts, maybe prod.env.h and test.env.h, that export the appropriate variables. Then just source whichever one you need before your session. Something like source prod.env.sh and Ionosctl k8s cluster list gives you a clean, documented way to switch contexts. The European data centers we use for production have different endpoints than our test environment, and this makes switching between them nearly effortless.
So we've got our configuration file set up for Ionosctl. That's going to save me a ton of time not having to specify my data center ID with every command. But I'm still curious about how authentication works. In my experience with AWS CLI, I've always had to manage access keys and secret keys. How does Ionosctl handle authentication?
That's a great question, Jordan. Think of Ionosctl authentication like entering a secure building. You present your credentials, that's your ID card, And once verified, you get what's essentially a key card that grants you access to specific areas. What I really appreciate about Ionosctl is it gives you two main authentication approaches, depending on your needs.
So what are those two approaches? I'm guessing one is just username and password, but that can't be the only option, right? How would this work when I'm trying to automate deployments in our CI/CD pipeline? Typing in passwords manually would be a nightmare.
You've hit on exactly why multiple authentication methods matter. Yes, the first is the basic username and password approach, simple but not ideal for automation. You'd use something like Ionosctl K8's cluster list, username john.do, password mysecretpassword. But you're right to be concerned. That method leaves passwords in command history and isn't automation friendly. For your CI/CD scenario, you'll want the second method, token-based authentication.
Tokens sound much better for automation. But wait, are these tokens secure? And how long do they last? Coming from AWS, I noticed their temporary credentials expire pretty quickly, which sometimes causes our overnight jobs to fail. That could be problematic if we're running long infrastructure provisioning tasks.
That's a pain point I've heard from many AWS users. Here's where I think you'll be pleasantly surprised with Ionos. By default, the tokens are valid for a full year, which solves that overnight job issue. But if you prefer shorter-lived tokens for security reasons, you can customize the expiration. For example, Ionosctl Token Generate, TTL30D, creates a token valid for 30 days. You can use years, months, days, hours, or even minutes. In production environments, I typically recommend 30-90-day tokens as a good security versus convenience balance.
That flexibility could save us time troubleshooting failed jobs. So once I've generated a token, how do I actually use it? I'm guessing there are multiple ways to pass it to the command line tool. Ideally, I'd want to store it as an environment variable in our CI system, rather than hard-coding it in scripts.
You're absolutely right, and that's the approach I recommend. There are several ways to use your token. You can pass it directly as a flag with token, your token here. But for your CI/CD use case, environment variables are much cleaner. Just set Ionos token in your environment, and Ionosctl will automatically pick it up without any additional parameters. Here's a pro tip from real production experience. Some teams create service accounts with limited permissions just for CI/CD, then generate specific tokens for those accounts. That way, if a token is ever compromised, it has only the exact permissions needed for automation tasks, nothing more.
So now that we've covered authentication, I'm curious about actually working with resources in Ionosctl. In my experience with AWS and Azure, each service has its own command patterns and syntax. How does Ionosctl handle this? Is it just as fragmented?
That's actually one of my favorite things about Ionosctl, Jordan. It uses a consistent pattern across all resource types. Think of it like a universal remote control for your cloud infrastructure. Instead of learning different commands for VMs, storage, networks, and Kubernetes, you'll use the same basic operations everywhere: get, list, create, update, and delete. This consistency makes the learning curve much gentler.
That could save us time. How would this work in practice, though? Let's say I need to set up some auto-scaling for our web applications. In AWS, I'd have to remember a specific set of commands just for that service.
Let me show you a common pattern with VM auto-scaling groups. To list your existing groups, you'd simply use Ionosctl VM auto-scaling group list. Need details on a specific group? Just Ionosctl VM auto-scaling group get with the group ID. Creating one follows the same logic. Ionosctl VM auto-scaling group create with parameters for data center, name, minimum, and maximum instances. Update and delete follow the exact same pattern. And here's what's great. Once you learn this for auto-scaling, you already know it for Kubernetes clusters, databases, and virtually everything else.
That does sound more intuitive than what I'm used to. With AWS CLI, I sometimes feel like I'm learning a new mini-language for each service. How's the performance and pricing with Ionos compared to the big players? Our team is always concerned about hidden costs that crop up later.
In production environments, I've found Ionos to be surprisingly competitive on pricing. What I really appreciate is their transparent billing. You won't find those mysterious line items that appear on other cloud bills. Performance has been rock solid for my enterprise clients, and being a European provider, their data privacy compliance is exceptional by default. Oh, and their support? Night and day compared to the ticket black hole experience I've had with larger providers. I had an urgent issue last month and got on a call with an actual engineer within hours.
Those are some compelling advantages. Do you have any pro tips for someone just starting with these resource operations? I'm always looking for ways to make our DevOps workflows more efficient.
Here's a pro tip. Use the output formatting options to integrate Ionosctl into your automation scripts. Adding output JSON to any command gives you structured data that's perfect for parsing. Another time saver is setting up environment variables or configuration profiles for common parameters. And don't overlook the wait functions for long-running operations. They're built right in, so you don't have to write polling logic yourself. Coming from AWS, I think you'll find the command structure more predictable and the documentation more approachable. The whole tool feels designed by people who actually use CLIs daily.
So, we've been working with all these resource operations in Ionosctl, but honestly, I'm getting a bit overwhelmed with the default output. In my experience with AWS CLI, I always end up piping to grep or JQ to make sense of things. Does Ionosctl have any better ways to format the output for different scenarios?
Absolutely. Output formatting is actually one of my favorite features in Ionosctl. Think of it like a restaurant menu. Depending on what you need, you might want just a brief list of dishes and prices, detailed descriptions, or maybe just the vegetarian options. Ionosctl gives you similar flexibility with your cloud resources.
That's a good analogy. So, what are my options? I'm particularly interested in how this would work when I'm building automation scripts versus when I'm just exploring resources interactively.
Great question. By default, Ionosctl gives you a nice human-readable table. Let me show you a common pattern. If you run Ionosctl K8's cluster list, you'll get a clean table with ID, name, version, and state. But for scripts, you can add output JSON to get structured JSON that's perfect for parsing. There's also output API JSON for the complete raw API response with all metadata.
That could save us time. One thing that drives me crazy with some CLIs is when I'm only interested in a couple of fields but get this massive table with 20 columns. Half the time I can't even read it without horizontally scrolling in my terminal. Can I customize what fields show up?
Oh, you're going to love this then. Use the Ionosctl flag to specify exactly which columns you want. For example, Ionosctl K8's cluster list, cols, name, state, will show you just those two columns. And here's a pro tip. If you're piping output to another command, use no headers to skip the column titles altogether.
Wait, so you mean I could do something like Ionosctl K8's cluster list, cols, name, no headers, and get a clean list of just cluster names? That would be perfect for feeding into a for loop in my deployment scripts. How does this compare to what you've seen in AWS or Azure CLIs?
Exactly. And in production environments, that pattern is incredibly useful. What I really appreciate about Ionosctl compared to some other cloud CLIs is the consistency. In AWS CLI, for instance, the output format can vary between services, which gets frustrating. With Ionosctl, these formatting options work the same way across all resource types, whether you're dealing with Kubernetes clusters, virtual data centers, or load balancers. Coming from other providers, that consistency is refreshing, especially when you're building complex automation.
So I've been getting the hang of customizing output formats with Ionosctl, which is super helpful. But now I need to tackle something a bit more complex. I'm setting up Kubernetes clusters for our new project. In my experience with AWS, managing Kubernetes configs can be, let's just say, tedious. How does Ionosctl handle Kubernetes management?
Oh, you're going to appreciate this, Jordan. Think of Ionosctl as your remote control for Kubernetes in Ionos Cloud. You know how K8's itself is powerful but complex, right? Well, our CLI tool simplifies the most common operations. Coming from AWS, you'll notice the commands are more intuitive. I was working with a client last month who cut their cluster management time in half after switching. What specific K8's tasks are you looking to streamline?
That sounds promising. My biggest pain point is always getting the kubeconfig files. With AWS, I'd have to navigate through the console, download the file, move it to the right directory. It feels like a lot of unnecessary steps. How would this work when using Ionos? I'm especially interested if there's a way to automate this for our CI/CD pipelines.
That's exactly where Ionosctl shines. Instead of clicking through portals, you can just run Ionosctl K8's kubeconfig get, cluster-id your cluster-id, and boom, you've got your kubeconfig. You can pipe it directly to a file or into your automation workflows. Here's a pro tip. For CI/CD pipelines, you can use something like Ionosctl K8's kubeconfig get, cluster ID ABC123, myclusterconfig.yaml, and then export kubeconfig to point to that file. What I really appreciate about the Ionos approach is how it streamlines these operations without sacrificing security.
Wait, so you mean I can just run one command and have my kubeconfig ready to go? That could save us time. What about Kubernetes versions, though? In my experience, version compatibility can be a real headache. Is there an easy way to check what versions are available or supported in Ionosctl?
Absolutely. Just run Ionosctl K8's version get, and you'll see what Kubernetes versions are currently available, including which one is the default. What's nice about Ionosctl is that they stay current with stable K8's releases, but don't force you to upgrade before you're ready. They also maintain versions longer than some of the bigger providers, which gives you more breathing room for planning upgrades. If you're working with the managed stackable data platform, there's a similar command, Ionosctl data platform cluster kubeconfig, to get those configs too.
That's actually really helpful. I've been burned before by forced upgrades with tight timelines. So, let me see if I understand the full workflow. I'd list my clusters first with Ionosctl K8's cluster list, then grab the ID of the cluster I need, and use that to get the kubeconfig with a single command. How's the performance of these clusters compared to what you'd get in AWS or Azure?
You've got it exactly right. List your clusters, grab the ID, then get your kubeconfig. As for performance, I've been consistently impressed. The underlying infrastructure is solid, European data centers with excellent connectivity. What I found working with several enterprise clients is that you get very predictable performance without the price fluctuations you might see elsewhere. One client actually moved their data-intensive workloads to Ionos specifically because they were getting better performance for lower cost, and their billing is refreshingly straightforward, no hunting through pages of line items trying to figure out where your money went. Have you started creating any clusters yet?
So, after our deep dive into Kubernetes management with Ionosctl, I'm curious about what's happening behind the scenes. Like, how is the tool actually talking to all these different services? I've worked with AWS CLI and Azure tools before, but I'm still getting my head around how Ionosctl handles all these different endpoints.
That's a great question, Jordan. What you're asking about is actually the service clients layer of Ionosctl. Think of them as specialized translators. In the same way you might need different translators for different languages, Ionosctl needs different service clients to communicate with each Ionos cloud service, whether that's Kubernetes, VMs, databases, or something else. Each service has its own API language, and the service clients know exactly how to speak it.
Oh, that makes sense. So in my experience with other cloud providers, I'd often have to learn different syntax or even use completely separate tools depending on what I was trying to manage. Is that the kind of problem these service clients are solving?
Exactly. Let me show you a common pattern. Say you're setting up a production environment and need both a Kubernetes cluster and a PostgreSQL database. Without service clients, you'd need to learn two completely different APIs, format requests differently, handle authentication separately for each. It gets messy fast. But with Ionosctl's service clients, all that complexity is abstracted away. You get a consistent experience regardless of which service you're using.
That could save us time. And so what specific service clients are available in Ionosctl? And how would this work when I'm, let's say, trying to script the creation of our entire infrastructure?
There are several key service clients built in. You've got the Cloud API client for core resources like VMs, storage, and networks. There's the Kubernetes client specifically for managing K8s clusters. Then there's the database as a service client for PostgreSQL instances. In production environments, I've found this particularly valuable because you can script everything with a consistent approach. Here's a pro tip. Even though you're working with different services, the authentication and command structure stays consistent, which makes automation much simpler compared to some other cloud providers I've worked with.
Wait, so you mean I don't have to juggle different authentication methods or command patterns when switching between services? Coming from AWS, where sometimes the CLI commands feel wildly different between services, that sounds surprisingly straightforward. What I'm really curious about is how these service clients actually work together in practice.
That's what I really appreciate about Ionosctl's design. Behind the scenes, each service client knows the specific endpoints, parameters, and response formats for its service. But from your perspective as a user, you get a unified experience. For example, when you run a command to create a K8s cluster and then another to set up a database, Ionosctl is actually using completely different service clients. But the command structure, authentication, and output formatting all feel consistent. I was surprised by how much this simplified our infrastructure as code practices when I implemented it for a fintech client last year. Their DevOps team cut onboarding time in half because engineers only had to learn one pattern that worked across all services.